Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, this is part 4 video on the chapter of rational numbers. In this video, I will discuss about the representation of rational numbers on the real line with some illustrative examples. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly request and suggest that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. This video is part of the playlist CBSE Maths 8 following the textbook of author R.S. Aggarwal. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side, and on the right hand side I will do all the discussion. So in this video I will discuss about how do we represent a rational number in the real line. So how do we mark the point representing a rational number in the real line. You have already studied in your previous classes how to represent rational integers on the number line. So you have so you know this is the number line. It's a straight line with two arrowheads on either ends, meaning it's the straight line will stretching infinitely on both sides, and somewhere in the middle you have the point. You mark the point as O, which represents the integer origin, and all the numbers greater than 0, that is positive numbers, you mark them on the right hand side of the origin, and all the negative numbers all the positive numbers you mark them on this side, right hand side, and all the negative numbers you mark on the left hand side of the point O. Now these positive numbers could be integers, natural numbers, whole numbers, or fractions or integers. So for integers you mark the points, you represent the integers, positive integers 1 or 2 at unit distances from the origin O. So let's say A, the point A is representing the integer 1, which is at unit distance from origin O to the right hand side. Similarly, the point B is at distance 2 units from the point origin O. Similarly, you will have all the integers marked this way. Similarly, for the negative integers, you have minus 1. Let's say this minus 1. Let's say this the value minus 1 is represented by the point A dash. It will be at unit distance from the origin O to the left hand side. Similarly, minus 2 you will represent with the point, say, B dash. It will be at 2 unit distance from the origin O on the left hand side. So this way you will have all the negative integers marked. So this is about, you have learned how to represent integers on the number line. In this video, in this chapter, we will discuss about how do we represent rational numbers on the number line. And when we represent rational numbers on the number line, that number line is known as the real line, because you have not studied yet about real numbers. Maybe you will study in class 9 about the real numbers, which are nothing but rational and irrational numbers. In this class you will study only rational numbers. In class 9 you will study about irrational numbers. So a real line is nothing but the number line where you can represent all the real numbers, and real numbers are rational numbers and irrational numbers. Okay, now so given a rational number, how do we represent that rational number in the number line? So I have divided case wise. I have four cases depending on what kind of rational number it is. There are 3 cases. How come? For me, 3 cases. No, there should be 4 cases. Okay, the last case number 3, it should be 4. Anyway, so the first case is given a rational number is p by q. P by q is the form of a rational number, and which is already in standard form, meaning the denominator is positive and the numerator and the denominator, that is p and q, have they do not have any common divisor except 1. and the rational number p by q is positive, that is p is greater than 0 and the rational number is less than 1, meaning p is less than q, that is the rational number is like a proper fraction. So you can see examples are 1 by 3, 3 by 5, 10 by 11, 19 by 13 and so on. How do we represent this kind of rational number on the real line? So since this is a positive rational number, the point will be definitely marked on the right hand side of the origin O. So what do we do is, if we take a point A, we take, so let me, how do I, can you see the notes properly? Okay. So I have, so let's say we are representing the rational number. So this is case 1. So you can also see the notes on the left hand side. You can see the notes and you can take a screenshot if you wish for your future reference. So while I am talking and discussing, I will discuss based on my notes, and you can also take a screenshot of the notes. So case 1 is where the rational number p by q is positive and p is less than q, that is it is a proper fraction. So we draw the straight line, the number line, that is the real line, and since we have to do all the drawing, the rational number p by q is positive, it will be on the right hand side of the origin O. It is better if you mark the point O somewhat to the left hand side, towards the left end. So let's say this be the origin O, and so this represents the value integer 0. Now what we do is, if we take a point A on the right hand side of the origin O, which is at unit distance from O. So let's say make keep the distance of the point A from the O, you should have a good amount of space so that you can do the markings and drawings. So I am marking the point A on the right hand side of the origin O such that this point A is representing the integer 1, so that the point A is at unit distance from the origin O to the right hand side. So I have OA equals to 1 and the point A is representing the integer 1. Now what I do is, I divide the segment OA into q equal parts. Why q? Because the rational number is p by q and q is the denominator. So whatever this denominator will be q, I will divide the OA into q such equal parts, and this distance, all this distance, these are the q equal parts. And the distance of these equal parts will definitely be 1 by q, since the whole distance OA, segment OA is 1 unit, and we have divided that segment OA. Let's say if this is a point, let's say q, then OQ, the distance OQ will be 1 by q, because we have divided the segment OA into q equal parts, and q is and OQ is such an equal part, so the distance of OQ will be 1 by q. Now what we do is, then we take p such equal parts. Where is p coming from? P is the numerator of the given rational number. So the given rational number is p by q. Q is the denominator and p is the numerator. So we have divided the segment OA into q equal parts, and then we are considering p such equal parts, and let's say p be a point such that OP is equal to OP is equal to p times equal parts, that is p into 1 by q. The length of each equal parts OQ is 1 by q, and I am considering a point between O and A such that OP is equal to p times such equal parts, where each equal part is of distance 1 by q. So OP will be p by q, which is equal to p by Q. So hence this point a P, therefore P will represent the rational number P by Q on the real line. Okay, so this was all about theoretical concept and discussion. Let's try to let's try to understand this with an example. Let's say I want to represent the number 3 by 5 on the number line. So I will take the number line and I will take the origin O somewhat towards the left end. So this will be O. I will mark the point, take a point A such that it represents the integer 1. So OA will be unit length. Now since we are trying to represent 3 by 5. We are trying to represent 3 by 5. So now the denominator is 5 and the numerator is 3. The denominator is 5, which is Q. So I will divide the segment OA into 5 equal parts. Roughly, it need not be perfect, but approximately or approximately you divide the segment OA into 5 equal parts. So let's say I divide 1, 2, 3 and 4 and 5. It may not be it need not be very exact marking, but roughly approximately. So I will have this. So this so let's say this so this marking, the first marking, so I divided OA into 5 equal parts. So each such equal parts, the distance will be 1 by 5. So definitely the first marking towards the right hand side of O will be 1 by 5. The second marking will be 2 by 5. The third marking will be 3 by 5. And definitely P, this marking 3 by 5 is representing the rational number 3 by 5. I hope it is clear. So the rational number we are representing is 3 by 5. If we mark the point A on the right hand side of O at unit distance from O, keep a good distance so that you can do the drawing, show the drawing properly. So the point A will represent the integer 1. Now I am dividing the segment OA into 5 equal parts, since 5 is the denominator. So 5 equal parts, and then I will in all such equal parts I will do the marking. The first part marking of the 5 equal parts, the first equal part will be at distance 1 by 5 from origin. The second equal part will be at distance 2 by 5 from the origin. This way you do all the markings. So in the marking 3 by 5, which is the rational number 3 by 5, that point will represent the rational number 3 by 5. So in this case we have marked the rational number 3 by 5 as the point P. Okay. So this was case 1, where the rational number is a positive rational number and it is of the form it is like a fraction, it is like a proper fraction, that is the numerator is less than the denominator, P is less than Q. Okay, let's come to case 2. Case 2 is similar to case 1, just that the rational number is negative. How do we represent? So case 2, so this is the notes, you can take a screenshot. Okay, so case 2 is the given rational number is minus P by Q, where P is greater than Q and P less than Q. P less than Q means if you consider only P by Q, it's a proper fraction. Proper fraction is where the numerator is less than the denominator. So P is less than Q. So we have in this case the rational number is of the form minus P by Q. So definitely it's a negative rational number, and where P is less than Q. Okay, so how do we represent these rational numbers? So the examples of these kind of rational numbers are minus 1 by 3, minus 3 by 5, minus 10 by 11, minus 9 by 13, etc. So what do we do? It is the same as exactly same as case number 1, but only that you just have to do the drawings all to the left hand side of the origin O. it is exactly like case 1, but since it's a negative rational number, you will do all the drawings on the left hand side of the origin O. So let's say I have the straight line, this is the real line or number line, and I will take this time, since I have to do all the drawings to the left hand side of the origin O, I will take the origin O somewhat towards the right end. So let's say this be origin O, and this will represent the integer 0. So I will take a point. Now it's a convention that when you consider points to the left hand side of the origin O, you denote it with the letters and a dash. So in this case, I will mark a point A dash on the left hand side of the origin O, or the left hand side of the origin O on the number line or real line, such that A dash is representing the integer minus 1, because it is on the left hand side of the origin O at unit distance from O. OA dash is 1, OA dash is 1, OA dash is 1. Hence, and since A dash is on the left hand side of the origin O, the point A will represent the integer minus 1. Okay. Now I will divide the segment OA dash into Q equal parts. Why? Q is the denominator. So I will approximately, roughly divide the segment OA dash into Q equal parts. So so the first part, the first equal part to the left hand side of origin O will represent the rational number minus 1 by Q. The second equal part will represent the rational number minus 2 by Q. The third one will represent minus 3 by Q, and so on and so on. It will so somewhere in between O and A dash there will be a point, let's say P dash where OP dash the length of OP dash will be equal to the OP dash will represent P such equal parts. Equal part here, equal part, or in the previous case, length of equal part is 1 by Q, where Q is the denominator, and OP dash is equal to P OP dash. The length of OP dash will be P such equal parts, length of P such equal parts, which is equal to P into length of a single equal part is 1 by Q. So the distance OP dash will be P by Q, and since P dash is on the left hand side of the origin O, the point P dash will mark the rational number minus P by Q. Okay, so let's try to understand this with an example. Let's say this time we use the number minus 1 by 3. How do we represent the number minus 1 by 3 on the real line or number line? So we will take the number line or the real line, straight line, and you mark the two endless end points with the pointer's arrow, and then you mark the origin somewhat towards the right end. Let's say this is the origin, which represents the integer 0, and you take a point A dash to the left hand side of the origin O at unit distance from origin O. So A dash will represent the integer minus 1. Now you divide OA dash into 3 equal parts, because the rational number is minus 1 by 3 and the denominator is 3. So I will divide OA dash into the segment OA dash into 3 equal parts. Let's say 1, 2 and 3. So definitely the first equal part, the marking of the first equal part to the left hand side of the origin O will be minus 1 by 3, and the second equal part will be minus 2 by 3, and so on. So and if P is the point of the marking, which is one such equal part, because the numerator is 1, So we have to take, as if you remember that we discussed, to represent the rational number p by q, we have divided OA dash into q such equal parts, and then we have considered the point p dash in between O and A dash, such that OP dash is equal to, the length of OP dash is equal to p equal parts, and where each equal part is of length 1 by q. So in this case p is 1, so we will take 1 equal part. So p will represent the point of the marking which is at distance 1 equal part, and 1 equal part in this case is 1 by 3. So we have so this is point p is representing the rational number minus 1 by 3. Okay, let's so you can take a screenshot of my notes. This is case 2. Okay, let's now discuss case 3. What is case 3? Case 3 is a rational number where it is of the form the given rational number is a mixed fraction. Case 3 is where the rational number is like, or is of the form mixed fraction, that is a and b upon c, a and b by c, which is nothing but, this is the mixed fraction a and b by c, which is nothing but a plus, a is the whole part and b by c is the fractional part. So this is a plus b by c. So we have a whole part, the whole part a will be an integer and b by c will be a fraction. And the case 3 we are considering that the rational number is a positive rational number, meaning that it's a positive rational number, and it is of the form a and b by c is a mixed fraction, a plus a and b by c we know is a plus b by c. Now you can also be this kind of a mixed fraction can also be represented as an improper fraction. For example, if you are given, let's say a mixed fraction 2 by 5. So this is a mixed fraction, but this, if you convert it as a improper fraction, this will become 5 into 10 plus 2, that is 12 by 5. 12 by 5 is a improper fraction. So you may be given 12 by 5 to represent on the number line. So 12 by 5, eventually if you are given an improper fraction, that is, an improper fraction is a fraction where the numerator is greater than the denominator. Here 12 is greater than 5. So if you are given a improper fraction, you have to convert it to first a mixed fraction. That is, if you are given 12 by 5, you have to convert it to 2 mixed fraction 2 and 2 by 5. We will actually discuss how we will represent 2 and 2 by 5 on the number line or real line. So case 3 is about a rational number which is like a mixed fraction, and it is a positive rational number, and it is the mixed fraction is of the form a and b by c, where a is the whole part and b by c is the fractional part. How do we represent this rational number in the number line? So we will take, so you can also see the notes while I am discussing. So you take the number line, the straight line or the real line, you draw the arrows to mark the two endless points, and then since it's a positive rational number, you take the origin somewhat to the left hand side. So let's say this is the origin, representing the integer 0. Now what do we do? Now first, so a and b by c is nothing but a plus b by c. First we will take a point b, we will mark a point b on the right hand side of the origin O on the number line, such that this b is representing the positive integer a. So this is the point b is at distance a units from O. So OB is a units. OB is a units. So OB is basically a units at distance a units from O to the right hand side. So somewhere here you might have the B is representing the positive integer A. So somewhere in between you will have 1, you will have 2, you will have 3 and so on. So let's say this could be A, C, D. Okay, but B is our distance A units from the point O. So B is representing the integer A, and what is A? A is coming from the whole part of the given rational number. Okay, now we take a point to the right hand side of the point B at unit distance from B, at unit distance from point B to the right hand side. Let this point be E. Let this be point E. Now the letters I am using in the discussion, it may not match with the one in the notes. So please ignore that. Please try to understand the concept. So I have marked the point B on the real line to the right hand side of the origin O at distance A units from O. Why A units? Because A is the whole part of the given rational number. Now I will mark the point E to the right hand side of B at unit distance from B. So BE is 1, is unit distance. So definitely the point E is representing the integer A plus 1. The point E is representing the integer A plus 1 because B is representing the integer A, and B and E, point E is at unit distance from B to the right hand side. Now what we do is we divide the segment BE into C equal parts. Where is C coming from? The fraction part of the rational number is B by C. So C is the denominator. So from the denominator C, we will divide BE into C equal parts. C equal parts. Let's say approximately C equal parts. And we will mark them, the equal parts. So the first marking, the marking of the first equal part to the right hand side of B will be the marking of let's say the first equal part. The first equal part to the right hand side of B is, let's say, this B F. So definitely we have BF is equal to 1 by C. BE is of length 1, and we have divided BE, the segment BE, into C equal parts, and BF is one such equal part. So BF will definitely be 1 by C. Now finally we will consider a point P such that at a marking such that the point P is at distance B such equal part. Now BP will be B times B, the point P will be at distance B by C. Actually this will be B into B times 1 by C from the point B. So then the point P will represent the rational number A and B by C. Because why is the P representing the rational number A and B by C? What does it mean? What does it mean that the point P is representing the rational number A and B by C? That is, it means that OP has to be equal to A and B by C, which is indeed the case, because we know OP is equal to OB plus BP. And what is OB? OB is equal to A. And what is BP? The point P has been taken in between B and E at that mark, which represents B such equal part. And what is an equal part? An equal part is where BE is divided into C equal parts and C equal parts. So point P is representing B such equal parts. That is, point P is a distance B such equal parts from B. So BP will definitely be B by C. So you see that OP is equal to A plus B by C, which is A plus B by C is nothing but A and B by C. So definitely the point P is representing the rational number A and B by C. I hope it is clear. Now case 4, is the same thing like case 5, but it is a negative rational number. It is a negative rational number. So you can see the notes, take a screenshot of the notes for your future reference. So case 3 is exactly similar to case 4. Okay, so before that, let's try to understand the case 3 with an example. Let's say we want to represent the rational number. Let's say we want to represent the rational number 2 and 2 by 5 on the number line. How do we do? So here we see that in this case a, the whole part is 2 and b by c is equal to 2 by 5. That is b is equal to 2 and c is equal to 5. I have written down so that it will be easier for us to refer while doing the drawing. So I will take the straight line and I will mark the end points, endless points, and since this is a positive rational number 2 and 2 by 5, I will take the origin somewhat towards the left hand side, and which will be the represent the integer 0. The first, so a is 2, so first I will mark the point B at distance 2 units from O to the right hand side. So let's say this is point B, which is at units. So this will be, so B will represent the integer 2. So let's say this be point A, which is representing the integer 1. So I have taken the mark the point B on the number line at 2 unit distance from O to the right hand side. So B, the point B will represent the integer 2. Now I will take a point C, or let's say point E, to the right hand side of B at a unit distance from B. Let's say this be the point E. Now the distance between B and C is very small, so it will be difficult to do the drawing. So let's say I have to make the unit distance a bit wider. So let's say the point B, let's say if I have to eventually take the point E. Okay, so let's say this is an approximate drawing. You need not do perfect drawing, and the measurements need not be perfect. So the point B will represent the integer 2 by 2 because the whole part in the rational number is 2. So this will be 2. So roughly this will be 1. Let's say this be A, even though this point A will not be required. Okay, so I have marked the point B on the real line at 2 unit distance from O to the right hand side. Why 2 units? Because the whole part in the rational number is 2. The rational number is 2 and 2 by 5. The whole part is 2. Now I will take the point E at unit distance from B. Let's say this be E. This be E. So since it is the point E is at unit distance from B and the B is representing the integer 2, E will represent the integer 3. 2 plus 1, 3. Now I will divide the segment. So we know that BE is equal to 1, OB is equal to 2. Now and also OE is equal to 3. Now I will divide the segment BE into 5 equal parts. Why 5? Because in the fraction part 2 by 5 the denominator is 5. So I will divide it into 5 equal parts roughly or approximately 1, 2, 3, 4 and 5. Now I will consider a point between B and E which will mark 2 such equal parts. I have divided BE into 5 equal parts, and 2 such equal parts from B to the right hand side will be this point. The point P will be at distance which is equal to 2 such equal parts, where one equal part is 1 by 5. 1 by 5 because we have divided BE into 5 equal parts. So the length of each equal part will be 1 by 5, and the point P length is a distance b which is equal to two such equal parts. Why 2? Because b is 2, the fraction part is 2 by 5, numerator is 2. So this point P will represent 2 and 2 by 5, because the point P is at distance 2 by 5 from B, and B is at distance from origin O at distance 2 units. So OP is equal to OB plus BP. And what is OB? OB is 2. And what is BP? BP is 2 by 5. So hence 2 plus 2 by 5 is nothing but 2 and 2 by 5. So the point P is representing the rational number 2 and 2 by 5. Now regarding the case 4 is nothing but similar to case 3, is just that the rational number will be negative. The rational number will be negative. So if you see the case 3, this is written case 3, but it will be case 4. You have the negative rational number which is of the form minus a. So case 4 is a negative rational number, the negative rational number of the form minus a and b by c, that is negative of a and b by c, negative of the rational number a and b by c, and a and b by c is a mixed fraction, and we just discussed how do we represent a and b by c on the number line. So all the drawings was to the right hand side of the origin O. This time to represent the negative rational number minus a and b by c, the drawings will be exactly same but to the left hand side of origin O. So let's directly try to understand this with an example. Let's say I want to represent the number minus 13 by 5, and I know that 13 by 5 is a negative rational number, and 13 by 5 is an improper fraction, and 13 by 5, I know that 13 by 5 is an improper fraction which can be represented as a mixed fraction as 2 and 3 by 5. 2 and 3 by 5. So minus 13 by 5 will be minus 2 and 3 by 5. So let's try to represent the rational number minus 13 by 5, which is equal to minus 2 and 3 by 5. So everything will be same, just we will do the similar drawings for 2 and 3 by 5, but everything will be on the left hand side of the origin O, since this is a negative of 2 and 3 by 5. So let's draw the real line, mark the two endless points. Since this time this rational number is negative, we will take the origin O towards the right end. So let's say this be origin O, this represents the integer 0. Now so in this case notice that a is 2. We know that we are ignoring the negative sign. We know that it's a negative rational number, negative of 2 and 3 by 5. So a is 2, b is 3, and c is 5. C is 5, because if it is of the form, if we consider that the rational number, the mixed fraction is of the form a and b by c. So in this case, if the mixed fraction is 2 and 3 by 5, a will be 2, the whole part will be 2, and the fraction will be 3 by 5. So, and the fraction is b by c, so b is 3 and c is 5. The values of a, b and c will be required to do the drawing. So first we take the point B to the left hand side of origin O, not B but B dash, at distance 2 from O. Why 2? Because A is 2. So let's say this be B dash, and so this will be the B dash is representing the integer minus 2. Since B dash is OB dash is the distance of OB dash is 2 units from the origin O to the left hand side. So the distance is 2. The distance is always a positive number. Do not never say that OB dash is minus 2. No, OB dash is 2. It's a distance. Distance is always a positive number. And B dash is representing the integer minus 2. Okay. Now, so this will be approximately represent the integer minus 1. Let's say this be A dash, even though we do not need A dash. Now we will mark a point E dash to the left hand side of B dash at the unit distance from B dash. So this will E dash will represent the integer minus 3. So we have B dash E dash is equal to 1. The distance of B dash E dash, segment B dash E dash is 1, since E dash is a point at unit distance from B dash to the left hand side. Now we will divide the segment B dash E dash into 5 equal parts. Why 5 equal parts? Because in the fraction part the denominator is 5, C is 5. So approximately we will divide B dash E dash into 5 equal parts. Let's say 1, 2, 3, 4 and 5 equal parts. Now since B is 3, we will consider 3 such equal parts. We will mark the point which is at distance 3 such equal parts from B dash to the left hand side. So this is the first marking. So the first marking of the marking of the first such equal part to the left hand side of B dash will be actually this will be minus 2. So we will consider. So we have divided B dash E dash into 5 equal parts. Why 5? Because the denominator of the fractional part B by C is 5. We have divided B dash E dash into 5 equal parts. Now we will consider 3 such equal parts. Why 3? Because B is 3. 3 such equal parts. We will mark the point. We will consider the marking which is at distance 3 such equal parts from B dash, which will be this point B dash, P dash. So P dash is ultimately representing the rational number minus 2 and 3 by 5. Why? Because we know that B dash P dash is equal to 3 into 1 by 5. Why? Because we have divided B dash E dash into 5 equal parts, and the point P dash is at distance 3 such equal parts from B dash. The length of one equal part is 1 by 5. So length of 3 such equal parts will be 3 into 1 by 5. So this is 3 by 5. 3 by 5. P dash is 3 by 5. And what is OP dash? OP dash is OB dash plus B dash P dash. And OB dash is, we know, is 2, and B dash P dash is 3 by 5. So this is 2 and 3 by 5. And since the point P dash is to the left hand side of the origin O, the P dash will represent the rational number minus 2 and 3 by 5. So these are all the major cases of rational numbers that you will be asked to represent on the number line or real line. Why is it called real line? Because you are up to class 7 you have learned that the number line where you draw the integers, you draw the integers and whole numbers, natural numbers. You have known that line as the number line. But once you are representing rational numbers, then this number line is known as real line, because this real line contains all the rational and irrational numbers. Irrational numbers you will study in class 9. So this brings to an end of discussing the how do we represent rational numbers on the real line. So we have discussed all the four cases, all the possible cases of rational numbers. So a rational number could be positive and it will be less than 1, that is like a proper fraction, or it could be a negative of a proper fraction, that is case 2. Case 1 was a proper fraction, that is a positive rational number where P is less than Q. Case 2 was same as case 1 but negative, that is a negative rational number where P is less than Q. Case 3 was it's a positive rational number of the form mixed fraction, that is a and b by c. So you have a whole part a and a fraction part b by c. Now instead of a and b by c, you could also be given an improper fraction, and we know that we can always convert an improper fraction to a mixed fraction. And the last case 4 was the same as case 3, was but a negative rational number, that is negative of a mixed fraction or negative of a improper fraction. So I hope this was clear, and I hope this video was beneficial to you. If it is, then please like it, share it with your friends, and please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by the you will be notified by my future videos. So in the previous video, part 2, I accidentally said that the chapter rational number was finished, but when I looked at the book, I found that a lot of more topics are left. So after the next video will be on all the properties, all the operations of rational numbers, that is addition, subtraction, multiplication and division, and their properties, and few some fundamental concepts about rational, and of course finding rational numbers between two given rational numbers. And then we will solve the subsequent problems from the exercise, that is 1b, 1c, 1d, and finally the objective questions. So the next video will be on understanding the addition properties of rational number, how it works and its properties, and some concepts like additive inverse and additive identity of rational numbers. So please stay tuned for the next video. Thanks for watching, and until the next video, take care and bye.